Good morning, this is Brenda Wingard-Haynes and this is Chem 110 and this is Unit 2 and I am preparing these, I'll call them ancillaries for Unit 2 in response to yet another snow day for spring 2019 semester. I'm at home, I've got 12 inches of snow in my driveway. And so usually and typically I'll use prior semester's notes to make sure I have exactly the same thing. But in lieu of that, I will be making new notes. So when I am done with the segments, I will upload these notes so that everybody in my morning and my evening class will have the same pieces of information. I'm also at home. You'll hear my dogs in the background. You may hear my cats meowing, the telephone ringing, various things, so I would ask that you just go with the flow on this. Okay, so this is going to be what I'm going to call segment 1. Okay, and so what you should do is you should have your blank notes in front of you and follow along with me. Okay, now Unit 2 introduces the language of chemistry instead of the numbers and the measurements that we did in Unit 1. Now, the fundamental working unit of chemistry is the actual individual atom, okay? So we need to look at how the atom is put together, how it behaves, and then we're going to make some predictions going from there. Okay, chemistry is the study of matter and its associated energy changes. In this class, we don't do a whole lot with energy, which is too bad. But matter is defined as something with mass which occupies space. Okay, so the fundamental unit of matter is the atom. Okay, now the atom is the smallest individual unit that you can have that's going to retain the property of that substance. And if you break it down any further, you have what we call subatomic particles. Now, for us in chemistry, we consider 3 of them. Okay, if you go to a physics class, you will have more than that. Okay, so our 3 fundamental particles are the proton, neutron, and electron, and I have put them in a chart here for you. Now, because the atom is so small, we have a made-up derived unit called an AMU, which is an atomic mass unit. And it's on the order of 10 to the minus 27 kilograms or 10 to the minus 24 kilograms. Either way, it's so small. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay? You can't weigh that, so you have to derive a unit. And our derived unit is the atomic mass unit, and we're going to say that the proton has a mass of 1 AMU. The neutron has a mass of 1 AMU, and the electron is approximately 0. Now, it's not really 0, it's that it takes about 2,000 electrons to equal 1 proton mass. Okay, so if you have, for example, your sig-fig rules, 1 proton, 1 neutron, 1 electron, and you add these together, our sig-fig rules say that all of this drops out. And that's why we are considering this to be 0, and this is why we laid the foundation in Unit 1 about sig-fig rules. Okay? Now your charge, your proton has a charge of +1, your neutron is neutral, your electron gets a charge of -1. The location of the proton and neutron is that they're in the nucleus, and the electron is outside the nucleus. And this is the crazy maker of this unit. The electrons, where are they and how we figure out where they are is what is more challenging for Unit 2. Okay, so if I ask you which 2 subatomic particles contribute to mass, you would say the proton plus the neutron. Okay, so the symbols I'm going to use are proton, neutron, electron. If I ask you which 2 subatomic particles contribute to charge, you would say protons with a positive charge plus the electrons with a negative charge. Okay? Page 2. We'll come back in just a minute to what happens when you change the balance of each of these. Okay, so the elements are the primary substances which are characterized by the number of protons. Okay, so in your folder there is a periodic table of elements. Depending on your class, you were given this list. Okay, so don't go anywhere without your calculator. Don't go anywhere without your periodic table. Okay, so if I have one proton, by definition, I am hydrogen. If I gain a proton, I'm no longer hydrogen, I am helium. If I gain another one, I became lithium, and so forth. Okay, so the element is defined by the number of protons. And if you take that element or atom, atom means one individual unit, element really means a collection of the units. Okay, so in its simplistic form, if this is my atom, or if I have an individual one, it's an atom. If I have a collection of them, it's an element. I'm going to have some protons, neutrons, and electrons. Kind of like if you broke an egg, although you can't really do that in practice. Okay, now the elements are named according to who discovered them, mythological figures, Greek and Latin languages, etc. Okay, so some of them are obvious. C is carbon, O is oxygen, Ti is from Greek mythology, referring to Titan, the large Greek god. Fm is fermium, which comes from Enrico Fermi, who is a famous physicist. Okay, so everybody either was given, or if you haven't been told this yet, this periodic table that is on the blackboard shelf for you, the ones that are circled are the ones that you have to commit to memory, both the symbol and the name. Okay, now I'm going to acknowledge that this is not particularly easy to read, and so what I would suggest is go to your book or go to Google, find another periodic table, and the ones that have a circle you need to know. You need to know that this is lithium, beryllium, sodium, magnesium, chromium, manganese, iron, cobalt, nickel, copper, zinc, blah, blah, blah. Anything that's circled, you are held responsible for. Okay? Now, depending on your section, you may or may not have an in-class warm-up. Depends on whether you've had a weather issue or whether you're a different semester or a different time of day or however that goes. The long and short is you must know these, and that's code for memorize. Because it is the basic language of chemistry, and if you don't know when I write down a C that I mean carbon, for example, you're going to be totally lost. Okay? The next segment will look more closely at the periodic table and how this is helpful to us.